Hi, hi teacher. Welcome to my presentation. And my name is Phạm Das. Today I'm going to talk about my project. Its name erode implicit impact detection using OpenCV operation. So my teammate is Lê Quang Dũng, and me Phạm Das, and Nguyễn Duy Anh, and my mentor is Dr. Nguyễn Văn Tới. So I introduced the table of contents, so we're gonna discuss the introduction to my project. We talk about data, and next we discuss in methods, and we show result and conclusion before I done this project. So, please pact is something that the most us see and use in our life. Um, we are mostly concerned with the use of the trust with and not trust in it and not the way they manufactured and pack the piece of pipe. So that state is extremely important to and can affect the user health. The pharmaceutical companies pay great attention to testing drug product and please the pact before delivering them to the customer. And there are many errors in the please the pack that's cut to treat errors such as missing drawers and many types of drugs in please the pack and the please the pack such as the missing drugs. Um, Many types of drugs in blister pack, and the blister pack with the missing and mix-up type of drugs. Imagine if the customer buys these blister packs and takes medicines, there are lots of catastrophic problems. Therefore, the aim of this project is classify the status of place the pipes correctly with the high accuracy and it takes a short time to process. Um, likewise, likewise, the data set is collected from the Avatec company, with the companies that provides a solution that use computer visions for industrial image processing. So we observed that the police packs were photographed on the product, the conveyor belt, and photographed from top to bottom with the softened light. Subs, the substance light. We also require some conditions such as the good light condition, especially viewpoints and no external environment impact. The constraint here is having no training model for using AI's model in the process and rest. And we do in this dataset with any placed pipes in this one. Therefore, our solution may be not useful in the other environment and other placed pipes. And now we can discuss about methods. Many methods we do in this project. So the problem we need to solve, we solve the methods. The first one, we have a diagram that we do in this project. The first one, we have to locate the blister in the picture. And next, before after we locate the pipes, we detect the field location and we locate the field in the pipe. And so the next, we check the field in the pipe, the number of field in the pipe. So we can conclude that if the number of fields is greater than threshold, is equal to 16, is please to pack it, okay, this is fully. But if not, it's place a error. If the place pack is full, we also check the few ties in packed. And so if the different type impacts the please the pipe, it is raw. And if not, everything done. So let's discuss how how do us locate the please the pipes. Firstly, we have to convert the image to grayscale, and next step is well helpful with we apply the binary threshold operation to make the line condition in corners and maybe more equal. After that, we erode the plisted pipes to the set their outlines, and we apply the bilateral filters were able to remove noise in the pipes without blurring corners safe. And before finding contour, we apply the candy filter to this origin we turn now image into light, and it makes the contour finding process become easy. Yeah, this the result before the first step, and we get the contour. And next to the next step, we locate fields in the pipe. So in an image, in addition to the pixel pipe contour, before we get the largest contour and locate the pipe in the picture, and now we want to locate the fields in the pipe. So the first one, we already we find the contour. We saw binary thresholding in the image. We find threshold in image, so we calculate the by do experience we set the binary thresholding at 190 or 190. So we find the areas of the fields, and we calculate the contour areas by using contour area operation, and we set threshold with greater than 1,000 and fit 1,500. It is a field, and it's not a field. So we find, and then we find contour in here. And so the next one, we use the bounding box rectangle operation, and we draw bounding box. We draw bounding box with respect to bounding box to corresponding to fields. It's also located the field in the image with respect to coordinates of bounding box. So before we got a bounding box of the fields, and we calculate the number of the field. If the number of the field, because we calculate the length of the bounding box in the pact. If the length is the length of is the number of bounding box in the pact, greater than 16, you know, it's 16 because the pact the pact is a one bounding box and the number of the field each one is one box. Total is 16 bounding box. If the equal the 16 bounding box, please byte it full. Else, if not, please byte it missing with fields. It's very simple. As you can see in the picture, it's a slide. The first one in the RGB in initial piece of pack. And so we do some tasks and some methods by using the traditional image processing. We got the bounding box of field and we conclude that and we define that this picture is a piece of pack missing. It's very simple. And after we have the bounding box in the image, which locates own image in our own fields in image, we created mask reasons for the fields to make the usable image region. And why we use mask? Because we use mask, we want to calculate the histogram in 8 fields. So we calculate a histogram for every mask region for every fields in image and compare them together and to check the fields types by using the compare hist with the correlation methods. If the difference between the two regions are bigger than the fixed threshold, I fix threshold with 0.8. 0.8 it means 80%. 80%. With 80%, this is the same type of field. If not, the pack were incorrect, and it's our checking process. Yeah, and then if the packs were greater than 80% correlated, and it's the same, it means the same. This the pack were correct, and our checking process was done. So the main method in here we do the histogram calculation methods by using OpenCV. In the picture here, we calculate mass, and we located the image as the field, and we calculate only this field with histogram, and we compare with the other field in the pack. So very easy. So after test process, our system worked pretty well. The accuracy up to 100%. Maybe it's incorrect in some picture, but I think it's okay with the constraints, and it's now it automatically detecting the error path. After we do this project, so I have some conclusion that the traditional image processing methods is enough to classify some picture error case, but deep learning is not always need in recognition problem. In here we don't have to use deep learning in this project, and we also we still classify or detect this path error. However, deep learning will be better if in more case and higher complexity, while a traditional digital processing is not handled under certain constraint. The last one, thank you for watching my presentation and hope you like it. Thank you so much.